Hello, my dear children. Yesterday we have discussed the type 1 sums. Okay, my dear children, I told you there are only three types of sums will be given in the continuity of a function. Now come to the type 2. The sums on testing continuity of a function at a point when the function has different definitions on both sides of the given point. Sometimes the function is defined in two different ways on both sides of the given point. In that case, we have to check, we have to discuss the continuity of the given function at that particular point. Now, to understand this type of questions, let us take an example. Question number 1, see, discuss the continuity of the function f of x at x is equal to 1 by 2, where f of x is equal to 1 by 2 minus x, comma 0 less than or equal to x less than 1 by 2. F of x is equal to 1 when x is equal to 1 by 2. F of x is equal to 3 by 2 minus x 1 by 2 less than x less than 1. Okay, my dear children, here the function is defined in three different ways. So here f is said to be a piecewise defined function. So here at x is equal to 1 by 2, we have to discuss the continuity of this function. Understood the question, my dear children? Right. See here, I am representing the given function pictorially on the number line. Let us consider this is a number line. Here 0, minus 1, here 1 by 2, here 1. Between 0 and 1 by 2, between 0 and 1 by 2, f of x is defined as 1 by 2 minus x. Between 1 by 2 and 1, f of x is defined as 3 by 2 minus x. Okay, my dear children, understood this diagram? F of 1 by 2 is equal to 1. When x is equal to 1 by 2, f of x value is 1. Okay, my dear children. So here at 1 by 2, we have to find the continuity of this function. So we have to find left hand limit of f at x is equal to 1 by 2 and right hand limit of f at x is equal to 1 by 2. As we have found yesterday left hand limit and right hand limit, here also we find left hand limit and right hand limit of the function at that particular point. So as x tends to 1 by 2 minus limit f of x is equal to, as x tends to 1 by 2, no need to write this sign here, limit 1 by 2 minus x. Instead of here f of x, I wrote 1 by 2 minus x, because as x tends to 1 by 2 minus, as x tends to 1 by 2 minus means x is less than 1 by 2. This implies f of x is equal to 1 by 2 minus x. If x value is less than 1 by 2, f of x is 1 by 2 minus x. That is why I took this function, not this function. Understood, my dear children? Right. Now we find the limit of this function. By direct substitution method, we find the limit of this function. So 1 by 2 minus x. X means 1 by 2. 1 by 2 minus 1 by 2. What will you get here? 0. So this is the left hand limit of this function f at x is equal to 1 by 2. Similarly, we find right hand limit of f at x is equal to 1 by 2. Right hand limit of f at x is equal to 1 by 2. Symbolically, we write as x tends to 1 by 2 plus limit f of x is equal to, as x tends to 1 by 2 limit 3 by 2 minus x. Why did we write here 3 by 2 minus x instead of f of x? Because as x tends to 1 by 2 plus means x is greater than 1 by 2. If x is greater than 1 by 2, what is f of x? Greater than 1 by 2 and less than 1. 3 by 2 minus x. That is why we wrote 3 by 2 minus x in the place of f of x. Understood this step, my dear children? Right. Now direct substitution method. To find the limit of the function, we use here substitution method. So 3 by 2 minus In the place of x, we substitute 1 by 2. Now we simplify these two numbers by taking LCM of the denominators. We get here 2. In the numerator, we get 3 minus 1. That is equal to, in the numerator, 2 by 2 denominator. By simplifying these two numbers, what will you get here? 1. This is the right hand limit of f at x is equal to 1 by 2. So if you observe here, left hand limit is 0 and right hand limit is 1. Both are not equal. Since these two limits are not equal, what can we say? We can say that the limit of the function f at x is equal to 1 by 2 does not exist. Do you remember that point, my dear children? Right. Here, as x tends to 1 by 2 minus limit f of x is not equal to as x tends to 1 by 2 plus limit f of x. It means left hand limit and right hand limit both are not equal. Then we can say that as x tends to 1 by 2 limit f of x does not exist. Okay, my dear children. Since it is not having limit at x is equal to 1 by 2, we can say that f is not continuous at x is equal to 1 by 2. Understood, my dear children? Right. Now, I am representing the given function pictorially. On the number line, see here, this is the number line, minus 1, 0, 1, 2, 3. Here, how the function is defined between 0 and 1, f of x is equal to 5x minus 4. So between 0 and 1, in this gap I am writing here f of x is equal to 5x minus 4. Between 1 and 2, if x value is lying between 1 and 2, then f of x is equal to 4x square minus 3x. So in this interval 1 to 2, f of x is defined as 4x square minus 3x. Understood this diagram, my dear children? Right. Now, here also we have to find left hand limit of f at x is equal to 1 and right hand limit of f at x is equal to 1. Okay, my dear children? We have to check the continuity of this function at x is equal to 1. That is why we are finding left hand limit and right hand limit of f at x is equal to 1. So, come to this part. As x tends to 1 minus limit f of x is equal to, as x tends to 1 limit 5x minus 4. Instead of f of x, I wrote here 5x minus 4 because as x tends to 1 minus means x is less than 1. If x is less than 1, see here 0 to 1, f of x is defined as 5x minus 4. That is why I am taking f of x as 5x minus 4. Now we are going to find the limit of this function by substitution method. So 5 into, in the place of x, we write 1 minus 4. Understood, my dear children? Right. What will you get here? 5 minus 4. By simplifying these two numbers, what will you get here? 1. So, left hand limit of f at x is equal to 1 is 1. Understood this part, my dear children? Right. Now come to RHL, right hand limit of f at x is equal to 1. As x tends to 1 plus limit f of x is equal to, as x tends to 1, limit 4x square minus 3x. We wrote here 4x square minus 3x instead of f of x because as x tends to 1 plus means x is greater than 1. If x is greater than 1 and less than 2, how the function is defined? F of x is equal to 4x square minus 3x. That is why we take this function only, not this function. Understood this step, my dear children? Right. Now we find the limit of this function by substitution method. So that is equal to 4 into 1 whole square minus 3 into 1. Just we are substituting x is equal to 1 in this expression. Then what will you get here? 4 minus 3. By simplifying these two numbers, what will you get here? 1. So here right hand limit of f at x is equal to 1 is also 1. Left hand limit of f at x is equal to 1 is also 1. Both are equal. Understood, my dear children? Right. Now we are going to find the function value at x is equal to 1. So f of 1 is equal to 5 into 1 minus 4, because f of x is defined as 5x minus 4 when 0 less than x less than or equal to 1. If x value is 1, we can take f of x is equal to 5x minus 4. That is why we are taking the function, and in that function we are substituting x is equal to 1. By simplifying these two terms, what will you get? 5 minus 4. Again, by simplifying these two numbers, what will you get here? 1. So finally here we got left hand limit and right hand limit and function value at x is equal to 1. All these three values are same. They are equal. Therefore, we can say that f is continuous at x is equal to 1. Hence, proved. Understood, my dear children? Right. Now, come to the questions of type 3. In this type 3, we have to finding the value or values of a constant given in the definition of a function when it is continuous at an indicated point. Here we have to find the value of a constant or values of constants if the given function f is continuous at that point. Okay, my dear children, to understand this type of questions, let us take one example. See, determine the value of k for which the following function is continuous at x is equal to 3. If the function f is continuous at x is equal to 3, in that case, we have to find the value of k. See here how the function f is defined. F of x is equal to x square minus 9 by x minus 3 when x is not equal to 3, and f of x is equal to k when x is equal to 3. Understood the question, my dear children? Here we have to find the value of k. Right. Now let us find the limit of the function at x is equal to 3. So as x tends to 3, limit f of x is equal to, as x tends to 3, limit x square minus 9 by x minus 3. Okay, my children? Right. That is equal to, as x tends to 3, limit numerator can be written as x plus 3 into x minus 3 whole divided by x minus 3. By striking out x minus 3, we get here only x plus 3. So as x tends to 3, limit x plus 3. Now substitution method. 3 plus 3, 6. So this is the limit of this function at x is equal to 3. And f of 3 is given as k. Read the question carefully, my dear children. You get this one. F of 3 is equal to k. As f is continuous at x is equal to 3, the limit of the function at x is equal to 3 and the function value at x is equal to 3 both are equal according to the definition of continuity of a function. This implies f of 3 is equal to k is equal to, what is the limit of this function at x is equal to 3? 6. Therefore k is equal to 6. We got here the value of k. Understood, my dear children? Right. Now come to the question number 2 of this type 3. Means we have to find the values of constants in the given function when the function is continuous. See here, if the function f of x given by f of x is equal to 3ax plus b, x greater than 1, x is equal to 1, f of x is equal to 1, and if x is less than 1, f of x is equal to 5ax minus 2b. Here f of x is defined in different ways. So here f is said to be piecewise defined function. Now it is continuous at x is equal to 1. It is already given that the given function is continuous at x is equal to 1. Then find the values of a and b. Now, understood the question, my dear children? We have to find the values of a and b. Okay, my dear children? So, I am representing the given function pictorially. See here, this is a number line 0, 1, like that. Below 1, less than 1. If x is less than 1, what is f of x? 5ax minus 2b. If x is greater than 1, what is f of x? 3ax plus b. So I wrote like this. Left side and right side of x is equal to 1. Means here we have to find left hand limit and right hand limit of f at x is equal to 1. Understood, my dear children? Right. So we are going to find the left hand limit of f at x is equal to 1 and the right hand limit of f at x is equal to 1. Previously we found left hand limit and the right hand limit of a given function at a particular point. We follow the same procedure. Okay, my dear children, as x tends to 1 minus limit f of x is equal to, as x tends to 1, limit 5ax minus 2b, because as x tends to 1 minus means x is less than 1. If x is less than 1, f of x is defined as 5ax minus 2b. That is why we wrote f of x is 5ax minus 2b. Understood this step, my dear children? Right. Now we are going to find the limit of this function as x tends to 1. This implies substitution method. So 5a into x means 1 minus 2b. By simplifying these terms, we get 5a minus 2b. Understood this step, my dear children? Right. Similarly, come to the right hand limit of f at x is equal to 1. So, as x tends to 1 plus limit f of x is equal to, as x tends to 1, limit 3ax plus b. Because as x tends to 1 plus means x is greater than 1. If x is greater than 1, f of x is defined as 3ax plus b. That is why we are taking this function only, not this function. Understood that step, my dear children? Right. Now we are going to find the limit of that function as x tends to 1. Means substitution method. So 3a into x means 1 plus b. By simplifying these terms, we get 3a plus b. So here we got left hand limit and here right hand limit. And also f of 1 is equal to 11. It is already defined in the question. Okay, my dear children. Now, as f is continuous at x is equal to 1, we get left hand limit and right hand limit and the function value at x is equal to 1. All these three values must be equal. This implies we got left hand limit. What is that left hand limit? 5a minus 2b is equal to, this is right hand limit. What is the right hand limit? We got 3a plus b is equal to f of 1, that is 11. So consider this is equation 1. Now we have to find the values of a and b. With the help of this equation 1, we find the values of a and b. Understood, my dear children? Right. Now from this equation 1, again we can write these two equations. See here, 5a minus 2b is equal to 11. I wrote as a second equation. Similarly, 3a plus b is equal to 11. I wrote third equation. Understood these two equations, my dear children? Right. If you observe these two equations are linear equations in two variables a and b. So we have to solve them for finding the values of a and b. So I wrote the second equation as it is, 5a minus 2b is equal to 11, and I multiplied third equation by 2. Then we get 2 into 3, 6a plus 2 into b. 2b is equal to 2 into 11, 22. Understood this equation, my dear children? Right. By adding these two equations, we get 5a plus 6a, 11a. These two terms gets cancelled, is equal to 11 plus 22. What will you get here? 33. Now this is a simple equation in A. We solve it. This implies A is equal to 33 by 11. If we are taking this 11 to RHS, it becomes by 11. So by simplifying these two numbers, we get 3. Therefore, A is equal to 3. Understood, my dear children? Right. Now we substitute the value of A in the equation 3. We get the equation 3. I am substituting A is equal to 3. So 3 into 3 plus B is equal to 11. Understood, my dear children? Right. This implies 3 into 3. What will you get here? 9 plus B is equal to 11. This implies B is equal to 11. We are sending this 9 to RHS. It becomes minus 9. Okay, my dear children. This implies B is equal to 11 minus 9. What will you get here? 2. Is it clear, my dear children? Right. So here we got A value is 3 and B value is 2. Okay, my dear children, we got the values of A and B here. Right.